so now we're going to go over some of the more challenging problems from the December 2016 exam, which some of you may have taken, so you might recognize some of these. We're going to start with problem 52, which asks us at what point the asymptotes of this function actually intersect. So this is actually a fairly difficult problem, but you could also kind of eyeball it if you know a thing or two about asymptotes. So you're probably more familiar with the notion of vertical and horizontal asymptotes. Vertical asymptotes happen when there's a spot in the function that's undefined. And here we could probably see from the graph that it's x equals 3. But looking at the equation, we could also say definitively that it's when x equals 3. When x equals 3, this denominator would be equal to 0, which is undefined in math. So we know that there has to be this vertical asymptote right over here. The function doesn't actually have horizontal asymptotes, which is what you might be thinking initially when you see a problem like this. You might see that it kind of dips down to around the 30 area and assume that there's a horizontal asymptote. But the function doesn't actually approach 30 and then taper off at that value. It actually goes back upwards, which means that we have sort of a diagonal asymptote, or what we call an oblique asymptote. So we know that we have this vertical asymptote, and we want to tell when it's going to intersect that oblique asymptote. And we can kind of assume that it's going to happen around this area here, if we have this vertical line intersecting with this diagonal line. So we can kind of guess, eyeball, that it's going to be the point 316. It's going to happen right around this value here. But to do it the long way, what we would do is we would actually complete this long division. We'd start by distributing out the denominator, which is, we'd distribute this 2x, and we'd end up with 2x squared plus 4x. And this is what we're going to be dividing by x minus 3. Let's sort of clear that so we can start fresh. So 2x squared plus 4x divided by x minus 3. Whenever we're doing long division with expressions, we go through the same process as we would long division with just numerical values. So we're going to start by doing this 2x squared divided by x. We get 2x up here, then we'll multiply each of these terms by 2x. Subtract this. These will cancel out. We have a subtraction of negative 6x, so that's going to be the same thing as adding 6x, and we're left with 10x. We go through the process again. 10x divided by x gives us 10, and then we multiply this 10 by both values here. Get 10x minus 30. Subtract both values, and we're going to end up with 2x plus 10 with a remainder of plus 30. Okay. This remainder is actually not going to be very important. As x gets larger and larger, this value is going to actually kind of disappear. So what we have here is essentially the equation of the line that we're talking about here, that sort of diagonal asymptote. We want to know how it behaves at x equals 3, because that's where our vertical asymptote lies. If we plug in 3 into this equation, we're going to get y equals 6 plus 10, or y equals 16. So at that point, x equals 3, where our vertical asymptote lies, our oblique asymptote has a value of 16, which again is going to give us answer choice J. So you could have done it by eyeballing it or doing it the long, tedious way. It really depends on how much time you have and your knowledge of oblique asymptotes.